Right, welcome back to Past Paper Walkthrough. Today we are doing the GCSE Chemistry higher tier for the AQA exam board. So, main thing to look for is you do have a periodic table that you can use, which I probably should prepare. And aside from that, you need a calculator, which I also have not prepared. So I'm gonna go grab that. Right, so the 100 marks available on the paper, which is standard. So without further ado, let's get started. So question 1, soluble salts are formed by reacting metal oxides with acids. Give one other type of substance that reacts with an acid to form a soluble salt. So for the first thing that you want to understand for this question is that you need to make a soluble salt, in which case you cannot make something like calcium hydroxide, which is not actually soluble. What you kind of want to make is things like sodium chloride or salts that are easy to dissociate. So if we find a type of acid, for example, you would think probably hydrochloric acid, which is HCl. And HCl does react with certain type of base. Any type of metal base would make a soluble salt. Or alternatively, you can also use the alkaline metal series on the group 1 of your periodic table, namely lithium, sodium, potassium, rubidium, and cesium, francium. Any of those would be acceptable. So I'm gonna say just alkaline metal as the answer. So that's one possible answer. There are many others. As long as they do make a soluble salt, you can use other things like any types of carbonate, any types of ammonium salt, and ammonium salt as of things that make ammonium salt, which is like a ammonia base, ammonium hydroxide, things like that. Then the second part is calcium nitrate contains Ca2 plus and NO3 minus. Give the formula of the calcium nitrate. So we basically want to balance the charge on this one. So Ca2 plus is 2 lots of positive charge, which requires 2 lots of negative charge to balance. So you need 1 lot of calcium and 2 lots of nitrate. So this is the calcium nitrate equation or formula. Then part 3 is describe a method to make a pure dry crystal of magnesium sulfate from a metal oxide and acid. So if we break this magnesium sulfate down, we can find the sulfate ion. That's SO4, 2 minus, and magnesium is just Mg2 plus because magnesium is group 2. You can verify it through the periodic table. So to make such a product, you need to use a dilute acid. It doesn't mention any type of strong or weak acid, so it's basically you can use the conjugate acid of the sulfate anion, which is H2SO4 or sulfuric acid, and magnesium you can make from metal oxide as specified from the question, which magnesium is 2+, which would pair up to 1 lot of oxygen anion. So you have magnesium oxide and H2SO4, so the equation looks sort of like this, and that would give you the magnesium sulfate plus water as your byproduct. So to make pure dry crystal of this, well, since this is a 6-mark question, it's gonna be a lot of experimental procedure that you need to talk about. So the first thing that you would do is to, initially you need to have a hot bath of dilute acid. So heat up the acid so that you get a, how should I put it? When you heat up the acid with the solution, it's gonna increase the, first of all, increase the rate of reaction of the magnesium oxide reaction, and second, it's gonna make the magnesium oxide more likely to dissolve. So then after heating up, you want to add the magnesium oxide and ensure the magnesium oxide is in excess. Because magnesium oxide is a solid, and so you can tell it is in excess when you've heated up the solution to boiling point, but they are still solid in the solution. So when that actually does happen, you get to that point, you want to do a gravity filtration. And that would remove the solid. And the solid being MgO. With that said, you now have a concentrated magnesium sulfate solution in water. That's just how the equation worked out to be, so I will actually just complete the equation up above. So that's balanced, and right, so what you have after adding excess of magnesium oxide into sulfuric acid and filter off the excess magnesium oxide gives you just everything on the left here. So magnesium sulfate solution in H2O. So what you need to do now is to get rid of the H2O. Luckily, magnesium sulfate is crystallizable. It can be crystallized from just letting the solution cool down gently. So you want to slowly cool the solution, and that would give you a even more concentrated solution of magnesium sulfate until it crystallizes. And after the magnesium sulfate crystallizes, you want to do another filtration, another gravity filtration. to remove the excess liquid. Now you're gonna get some white crystals. If you have came across magnesium salt before, all of them are white in general, unless they're in some sort of a weird complex kind of situation that is beyond the scope of GCSE or even A level, so don't worry about them. So magnesium salt make white crystals, and now they're on the filter paper, and you can just let it dry. So yeah, that would give you some pretty pure dry crystal of magnesium sulfate. So that would give you a good 6 marks. Make sure you also talk about how you're gonna heat the solution, like say use a Bunsen burner or something like that. Make sure the magnesium oxide is in excess is important, because otherwise you're gonna have magnesium oxide in your crystals, and that wouldn't be pure. Then slowly cool the solution to make good pure crystals. You can also actually chill it to force it to crystallize faster, but that would make not so nice small tiny powder crystals or even amorphous solids, which would not be ideal for your application. And yeah, when you do filtration, specify gravity filtration. Make sure you let it dry, otherwise they're a bit pedantic about how they give scores. So yeah, it's just mark scheme really. If you've came across recrystallization kind of question, it's just similar procedures. So that's it for question 1. Question 2, part 1, iron pyrite is an iron compound, ionic compound, and figure 1 shows a structure of iron pyrite, rather. Determine the formula of iron pyrites. So you've got 1 iron to 2 sulfur, which is FeS2. That's it, simple, hence 1 mark. An atom of iron is represented as 5626 iron. Give the number of proton, neutron, and electron in this atom of iron. So first of all, we know that the number of proton is in the proton number 26, so there you go. Number of neutrons, let's skip that for now. Go to electron, we know that this is an atom, which means that it's not ionic or non-charged, which means that proton number equal to electron number. So you also have 26 electrons. And finally, in order to find the number of neutrons, you subtract the total mass number, 56, using the atomic number 26, which gives you 30. So 30 is the difference between the mass number and the atomic number, and that would give you the number of neutrons. So that's 3 mark 3. Iron is a transition metal, sodium is a group 1, give the difference between the two. So for this one, you can talk about their relative reactivity. So sodium, as we know, reacts with water, and iron also does react with water in the presence of oxygen. That's got rusting. But sodium does react a lot more vigorously because it is an alkaline metal, which means that you can say that sodium is more reactive. So that's 1 mark. And then you can think about in terms of, say, the applications, say, transition metals have been vastly studied as a potential catalyst in many reactions. So you can say that iron is a potential catalyst. And aside from these two, there are many more. Sodium is soft in comparison to iron because you can use just a scalpel to cut sodium into pieces, whilst iron you probably need a power tool or some machining, machine shop machines. And in terms of their density, sodium does float on water, whereas iron does sink. Iron can have a 2+ oxidation state and 3+ oxidation state, whereas sodium can only have 1+. And iron makes hydroxide ions that has a color, whereas sodium hydroxide is colorless. So things like that all would score you different marks, and as long as you can give any of the two, you can get the 2 marks in this part of the question. Now, going to 2.4, explain why carbon can be used to extract nickel from nickel oxide. And before then, the question actually told you that nickel is extracted from nickel oxide by reduction with carbon. So you can say what reduction is, remember, is oil rig. RIG is reduction, is gain of electrons. So we know that the nickel has gained electron in the process, so it went from a nickel, let's see, in terms of oxidation state, we have no clue as to what nickel oxide actually is, but, well, we know that the nickel oxide has turned into nickel metal and carbon dioxide because you used carbon in the process, and carbon and oxygen makes carbon dioxide as a stable product. And to make this equation actually go the forward direction, the carbon has to be more reactive than the nickel. So with this insight, we can just say because of that, the carbon will substitute the nickel ion, and so you can use it to extract nickel from nickel oxide. So the 2 mark comes from either saying what reduction is in terms of electrons. It can be from saying that carbon is more reactive than nickel, and talking about carbon replacing the nickel ion. And yes, if you do read the next question, if you were stuck, you skip the first part, you would actually be provided with another equation that is used in nickel reduction. and I obviously should balance this one, so it should be 2 and 2 here. But if you can't get your head around this, you can always skip the first part and see if subsequent parts give you any more information. Now you have nickel monoxide plus carbon goes to nickel plus carbon monoxide, so you want to calculate the atom economy for the reaction. So basically you want to find the product weight and the nickel weight. So nickel is 59, whereas everything on the right you have carbon monoxide, which is 12, plus oxygen, which is 16, gives me 28. And so everything on the right is $87. So everything on the right is 87, and in order to find the atom economy, you want to find the amount of nickel yielded over the MR of all the product, which is 59 divided by 87. And if we use the calculator, we should get round about 67.8%, and make sure you multiply by 100% to get the proper unit, otherwise you're gonna get 0.678. And make sure you do 3 significant figures as they told you, so that's 67.8. And note that the nickel oxide formula mass is completely unnecessary. I don't know why they put it there, but hey, that's what people do to confuse you, huh? Now, moving on to question 3, which is electricity related. And we have a simple cell. Which of these two will not give a 0 reading on the voltmeter in figure 2? So figure 2 is just you've got 2 electrodes in electrolyte. And so basically you just want to find a situation where the 2 electrodes have a different reactivity and the electrolyte can carry that ion. So that rules off the first and the second one, because copper and copper have the same reactivity, zinc and zinc have the same reactivity, so they are not right. Then we have the copper, zinc and sodium chloride, whereas copper, zinc, water, so the 2 electrodes on these two are identical, so what we're looking at is the electrolyte. So which one conducts electricity? We know that sodium chloride solution does, and we know that pure water doesn't. Hence, the only correct answer is the copper, zinc and sodium chloride. So that's quick and easy. Alkaline batteries are not non-rechargeable. So why do alkaline batteries eventually stop working? So the fact about battery is that it's driven by a chemical reaction. So when all reactants gets used up, the current drops to 0, and hence it stops working. And why can alkaline batteries not be recharged? So this one is on the surface, you would think that you would need to know how this an alkaline battery work, but really all you need to say is that the reaction is not reversible, so you cannot actually charge it even if you put in current. So just say the reaction is not reversible, and that would give you the last mark on this, well, the only mark in this part. Then you have part 3.4, complete the balance equation for the overall reaction in the hydrogen fuel cell. So a hydrogen fuel cell consumes hydrogen gas and oxygen gas. And as you can try to balance the oxygen, 1 lot of oxygen gas gives 2 lots of water, because then you need 2 atoms of oxygen. And on the right hand side now, you have 2 times 2 lots of hydrogen, which is 4 hydrogen atoms. And on the left, that would equate to 2 lots of hydrogen gas, molecular hydrogen, that is. So that would be balanced. You can also use a fractional value of oxygen if you wish. So you can do half a mole of O2 gas plus 1 lot of H2 gas goes to 1 mole of H2O gas, liquid. So that's the 2 marks. We have part 3.5 now. And we have some data about electric cars with hydrogen fuel cell cars and lithium-ion battery cars. And now we need to talk about the 2 differences. Right, so in terms of the actual question, you need 6 marks, so you need about 3 arguments for and against each option, and also you need to use correct English or reasonable arguments, and so you can actually answer this in either way. So if, say, I want to say that hydrogen fuel cell is better than the lithium-ion battery, then first of all, we are going to talk about the time taken to refuel and recharge. So it's much faster to refuel a hydrogen fuel cell car than charging a battery. That's just how the batteries nowadays work. And so this is a clear advantage on hydrogen fuel cell cars. And also hydrogen fuel cell cars does have a higher range, so you can travel a further distance without recharging or refueling. Now, with that said, you can also apply some extra knowledges. So hydrogen fuel cell obviously use hydrogen and oxygen, as we have discussed above, and hydrogen and oxygen can come from hydrolysis of water, which could be powered from solar panels or renewable energy sources. So in theory, hydrogen fuel cell is a zero carbon kind of driving technique. So you've got the zero carbon advantage versus lithium-ion battery, which uses mains electricity, and as we all know, mains electricity is mostly fossil fuel powered. So that is one advantage. And hydrogen fuel cell only makes water as a byproduct, so it's a clean alternative to normal cars, but in comparison to lithium-ion battery, it does not, well, it does have a byproduct of water compared to literally no byproduct at all. And so you can also talk about the in terms of the argument from the lithium-ion cars, you obviously cannot use the distance travel and the time taken to refuel, but these two, well, these 3 points are all for lithium ions, so refueling is much cheaper, and also the energy efficiency for using electricity to directly power the engine is much higher than as you would just burn hydrogen on the go. And the minimum cost of lithium-ion battery cars are much cheaper because the industry is much more developed. You can also name the company Tesla, as their electric cars are probably the most common in the world at this moment in time. And the argument for the carbon production is that you can also fuel your car with solar panels, and you can argue that hydrogen fuel cell hydrogens are made from fossil fuel. There is a reaction which convert methane into hydrogen and I think carbon dioxide. So that is a possible argument for the lithium-ion battery. So basically, you just want to talk as much about their relative advantage and disadvantage as you can within reasonable time. So typically, how I would tackle these kind of questions is that I would write down a few obvious things in either argument, then skip the whole question till the end after you've answered every other questions, then come back to elaborate on your points. So basically, you want to gain the fundamental 4 marks from content, then go for the 5th and 6th mark by elaborating your reasoning. So that's this question. I'm not going to bother writing everything that I've said, but I've explained plenty. Question 4, we have the atomic models. So 4.1, which is the plum pudding model of the atom. So it cannot be the first one, it cannot be the third one, and I literally do not know what D is. That's a hard sphere model, isn't it? Then you have the B and E, which are the potential correct answers. You have a positive charge cloud with negative dots in them, and you have negative cloud with positive dots around it. So what these dots are simulating is the electrons, and we know that electrons are negative, so it has to be B. And which diagram shows the model of the atom developed by the alpha particle scattering experiment? And we must tick one other box, and it's so alpha particle scattering, or the gold foil experiment, involves shooting alpha particle into a thin sheet of gold and see if any backscattering happens. So if a backscattering does happen, that would mean that there is a kind of concentrated positive charge rather than the bomb putting positive field of charge. So there are A and C as our potentially correct answer, and for this particular one, to be fair, I would say A and C are both correct, but in reality, C is the closer correct candidate, because C assumes that all electrons orbit at the same orbit radius around the nucleus, which is assumed to be only positive charge without neutrons. And that was how history evolved to be. So yeah, to be fair, A, I personally think it's correct, but I don't think the mark scheme says so. Then which diagram shows the model from Bohr? So the Bohr model is the one with distinct different energy orbitals and layers of energy. The first orbital has 2 electrons, then second with 8, then so on and so forth. So A is the only one that applies to the Bohr model. And this is also the reason why 4.2 cannot be A, because you're not going to have the same multiple choice on the same kind of on 2 different answers. So that's just, I think it's a bit stupid, but I think it's just playing the exam games. Now 4.4, define the mass number of an atom, which is just the number of protons. And neutrons. So NEUTRONS. Now we have element X, which has 2 isotopes, 69 and 71. 60% is 69, 40% is 71. So find the relative atomic mass, which, let's see, so it is not 69 or 71, because it just isn't. The average of them, weighted average of them, cannot be the extremes. And so we're ignoring these 2. So the 50-50 average of these 2 mass number is exactly 70. But we know that it's weighted towards the low end, 69. So it is between 69.5 and 70. So that's the correct answer. If you want to actually do the math, it's 0.6 times 69 plus 0.4 times 71. And that would give us 69 plus 0.4 times 71 gives me 69.8, which is between 69.5 and 70.0. So that also lead you to the answer. It's just one way is faster than the other. Now, Chadwick's experimental work on the atom led to a better understanding of isotopes. Explain how this work leads to this understanding. So if you did do your history lessons in the chemistry domain, then you'd know that Chadwick has done an experiment that showed the existence of neutrons. So show the existence of neutrons. And so with that, we can now explain what the isotope is, what the idea of isotope is. So isotopes are atoms of the same element because their proton numbers are equal, but with different number of neutrons. So there's 1 mark allocated here and 2 marks allocated here. So basically what you want to say is atom of the same element is 1 mark, different number of neutrons is the 2nd mark. So that's again, it's bookwork, you remember this, standard things, it's just definition mostly. And now we move on to question 5, which would be the last question of this part of the video. Student investigated temperature change in displacement reactions between metals and copper sulfate reactions. So in this case, displacement reaction is basically substitution. I didn't mean to cross out displacement there, but well. So copper, iron, magnesium, and zinc, to substitute copper to get the whatever sulfate it makes. So copper obviously doesn't substitute copper because there's no reason for it to, because they're identical from the start and finish. So the temperature increases 0, which is fair enough. Iron is more reactive than copper, so the displacement reaction is exothermic, making the temperature increase 13 degrees. Then magnesium is more reactive than iron, so the reaction goes much faster, and so it heats up a lot more. Whereas zinc is just in between iron and magnesium in terms of reactivity, more towards the iron side of things, so it's a 17-degree increase. So now we're gonna plot the data from table 2 on figure 4 as a bar chart. Oh dear, I don't like plotting. So let's say we need to get up to 50. So we have 1, 2, 3, 4, 5. So we can say 50 is here, 0 is here in terms of increase in temperature. It's 40, 30, 20, 10. Now metal, we have the 4 kinds, so I'll just say copper, iron, magnesium, and zinc. So copper is exactly 0, so it's right there. Iron is 13, so that is 13 right there. Magnesium is 43, which is 40 plus 3 right here. And finally zinc is 17, which is 20, take 3, which is there. So again, we need to express it as a bar chart. So we're gonna draw in. So you can decide on how wide your bar chart is and whether you want to space out your bar charts, but basically you just need to do things like that, and so that's pretty much it. It didn't say you need to put them in specific orders, so that would be fine. So 2 marks. I always think that plotting should be worth more than 2 marks because it's just a waste of time, really. It doesn't really do much in terms of chemistry knowledge, but that's what exam boards want, so oh well. Now, the student concluded that the reaction between the metal and copper sulfate are endothermic. So endothermic means that heat is absorbed into the reaction, which should make the environment cooler. So that would actually decrease the temperature measured. And so this is not right. So you can either say because the temperature increased or because the temperature didn't decrease. I'd say, if I can spell, temperature increased. So that's 1 mark. It's pretty simple. Part 3, the temperature change depends on reactivity of the metal. And the student's result are used to place copper, iron, magnesium, zinc in order of reactivity, describe method to find the position of an unknown metal in this reactivity series. Method should give valid results. So what you want to do here is to find a different different method of finding reactivity. The easiest one is to put all the metals in acid. So if you just use acid as a kind of reactivity gauge, and if you control the acid concentration, and you can add in the metal, ensure they are same moles and surface area, and you measure the rate of reaction. This can be from the production of hydrogen gas, and then after that you just need to order using the rate measured. So I've checked the mark scheme, and this is actually apparently important. So I thought it's assumed to be ordered using the rates, because why else would you measure the rate? Apparently you need to explicitly write it out. So yeah, if you don't explicitly write it out, then you're only gonna get 3 marks despite a perfect answer, so that's a bit stupid. But again, examiners, they do things that we don't understand. So that's the 4 things that you can do. Aside from using acid, you can also use metal salts and find displacement results similar to what the previous question did. And you can measure the change in temperature for reactivity, things like that. And yeah, the next part is 5.4 and draw a fully labeled reaction profile in zinc and copper sulfate. Again, if we look back up, zinc is 17, increase in temperature. So this is exothermic, which means that the reactant is higher in energy than the product. So you've got reactant and product. So this is the product. This is the reactant. And now all reaction profile has an activation energy. So you need to label this as EA, which is the activation energy, and this difference in reactant and product height is the delta H, or the heat of the reaction. So that's it, basically. You can't add more to this aside from adding the actual reaction equation, but I don't think that matters in this context. So as long as you label the activation energy and the delta H, then your profile should be completely labeled. So that's it for this video, this first part, and I'll come back next time to talk about the question 6 till I think question 9 of this paper. So hope you've learned something, and I'll see you next time.